Dear students, today we will be learning about the Franck hertz experiment. In this experiment, we will learn that the energy levels of the given gas, which is argon in this experiment, are quantized. So as you can see that this is a glass tube in which argon gas is filled, and you can see electrodes at one end, at the other end, where you can actually apply different potentials using different potential knobs which are given on the instrument Vg1K, Vg2A and Vg2K. The K and the A stand for cathode and anode respectively, and Vg2K is the bias which is applied between grid 2 and cathode K. So if you look at the diagram of the gas discharge tube which is there in the manual, what you see is that there is a filament at the base which is marked as K. This is the cathode and is responsible for emission of the electron stream. And to eject the electrons, a potential Vg1K is given. In this experiment, the value of Vg1K will be fixed at 1.5 volts. The electrons are then focused using the potential at G1 and travel towards grid 2. Now as you can see that the potential Vg2K is applied between the cathode and the grid 2. So the electrons are actually accelerating between this region. And then there is one more battery which is applied, named as Vg2A, where the polarity is such that the negative of the Vg2A battery is connected to the anode. So the electrons which pass through grid 2 will reach anode A if and only if they can overcome the force of repulsion between anode and their flow of direction flow. Now ammeter is associated or attached in the circuit of Vg2A, G2 and A. So only those electrons which are able to overcome this gap or the retarding potential will flow in this circuit, and we will be able to monitor the current. Now what happens is, as you start increasing the potential Vg2K, more and more electrons are actually passing through, or they're gaining energy. And as they gain energy, they bombard with the argon atoms and lose the energy to argon atoms. Now if argon atoms have gained a sufficient amount of energy to go from their ground state to the first excitation potential, what we will observe is a dip in the current. The reason is the electrons which were reaching here were gaining enough energy or sufficient energy to overcome this barrier, and then they were able to flow in this circuit. Now these electrons which are accelerated are somewhere in between, losing their energy to the argon ions or argon atoms, so to say, and hence there is a dip in the current which is observed. Now in this experiment, as you will change the potential from 0 volts to 90 volts, you will see that the current profile increases, decreases, increases, decreases, and so on and so forth. So the reason for this increase is that you are changing the energy of the electrons by applying more and more potential. But the dip that you see in the current is due to the fact that at the first excitation potential, the electrons have actually lost all the energy in exciting the argon atoms. Hence, there are no electrons that reach the anode plate, and if they are not reaching the anode plate, we see a dip in the value of the current. So in this experiment, all you have to do is monitor the current on this meter while do few settings first. So Vg1K is supposed to be 1.5 volts. So just turn the knob to 1.5. These minor fluctuations are allowed. And then you switch the knob to VG2A. This value is supposed to be 7.5 volts. The knob is sensitive, so you have to touch it very gently. Yeah, that should be fine. And then finally, VG2K is the potential that you have to vary. So you can see that at about 0.6 volts, the corresponding current is 0. Now what you have to do is gradually turn this knob and take the readings for every 1 volt difference. So at 1 volts, read the current value. Then increase this to 2 volts. Do it gradually so that you don't overshoot the point where you have to take the reading. So read it for 2 volts, similarly 3 volts. So for every 1 volt, you have to read the voltage and the current values. And then, now for demonstration purpose, I am moving it a little faster, but you have to do this experiment gradually. So for every 1 volt, you will be recording the reading. So for example, 29 volts, you have a current of 0.11, 10 to the power minus 8 ampere. Likewise, you have to do to 90 volts. So we have reached 89 volts, and then the last reading is at 90 volts. Here you stop, monitor the current and plot the graph between the current on the y-axis and the accelerating voltage on the x-axis, and do corresponding calculations for the first excitation potential. Thank you.